and hello everyone. Today we're gonna talk about AI solutions tools, but in action. So Bastien has presented these tools before. Now we're gonna see how to use it to recognize sign language. So we will use a use case related to the health sector. And before starting the presentation, I will introduce myself very quickly. So I'm Elea Petton. I'm working as a machine learning engineer at OVHcloud, and I'm part of the wonderful team named AI Solutions. So, quick words on the OVHcloud. We are the French and European leader in the cloud. We are focused on data privacy and sovereignty. We are also not subject to the Cloud Act, and we have the HDR certification, which is really important for data in the health sector. On the right, you can see all the other certifications. And last but not least, we are in collaborations with the public sector. Concerning our values, the first one is the trust, because we trust in each other and we would like to have a trusted cloud. We are also working together with patience, disruption, and of course, responsibility. Today, we're going to talk about the public cloud offers, and to be more precise, the AI offers, but we have other products that you can see here, and you are able to check on our website what you want to do. Concerning the location, we are in France, in Europe, but also in all the world. Okay, so let's go for AI tools. So Bastien did the presentation before, but just to sum up, AI notebooks, the first one, you can do some data exploration, you can build a model, train it, test it, thanks to GPU power. After that, you have AI training. You can launch AI training jobs very quickly with a simple Python file, for example. And you can also use your own Docker image if you need it. And the last one, it's not made for the training, but for the deployment of AI models or AI apps. So you can develop some API or some apps or everything you want with a simple Docker image. Okay, so today we want to recognize sign language. To do it, we will use a computer vision field and, to be more precise, the object detection task. In computer vision, you have first the classification with a single object. You can add the localization. And when you have several objects on an image or on a video, for example, with boxes, you have the object detection. We're going to focus on this method today. You have also the instance inclusion with more precise detection. Concerning object detection, what we want is to have the object on the image, a box with a label or the name of the class, and also a probability between 0 and 1. So that's for the context, but today we're going to use an existing algorithm named YOLO, and to be more precise, YOLO v7. So YOLO is for you only look once. YOLO v7 is part of YOLO family. It's not the last one. A few days ago, we have seen that there is now YOLO v8. So today we will use this algorithm, but we can totally do it with the last one. This model is made for recognize, and you can also detect various objects on photos or on videos, and you can do detection in real time. Why using this model? Because it's really fast and accurate. In practice, we're going to train YOLO v7 model. So we will have a custom model with our custom data. We will do some detection with the computer webcam to have the real-time detection. And at the end, we will have the results. We will display the results, and we will also save it. Why? Because today we will detect American Sign Language letters. not all the sign language because it would be too complicated. It's a POC only. So I will do a letter, for example, here a W. And after that, I will save the letter to write a word at the end. So let's go for the journey to American Sign Language alphabet detection. First, we have the dataset. That's OK. After that, in an AI notebook, I can do some data processing, for example. I will also create the model, or in our case, we will use an existing one. We will train it, and we will evaluate it on the test set. If my model is not good enough, I can do some data processing again with data augmentation, and after that, I can train again the model, evaluate it on the test set, and if my model is good, I can store it in an object storage container. Now it's time to use the model to develop an app. So we can develop it with Fast API, for example, or Streamlit in our case. And we will use a Docker image. You will see it is very simple. And we will deploy it thanks to AI deploy. After that, we will do some real-time detection. First of all, we will focus on the AI notebooks part, and we will do some tests. OK, so let's go. Here, I have already launched an AI notebook, an OVHcloud AI notebook to be more precise. I use the framework named Miniconda. My notebook is a Jupyter lab. I will use the PyTorch library, and also weight and biases to see the results. Weight and biases is a framework to see the evolution of a model during the training. It's very useful, and you will see that it's very important to compare models during a training. So I will access to my notebook. OK, so I will just zoom. OK, here you can see several things. First of all, on the left, you have AI training example. What is it? This is a GitHub repository from OVHcloud. You will have all our tutorials, all the examples, and so on. After that, I have the YOLO V7 model. I will store my model after the training in this object storage container. I have also my data. So concerning the data, I have chosen a public dataset available on RoboFlow. You can download it for free, no problem. And I have just stored it here. So you have the training set, the validation set, and the test set. You also have the data.yaml file. I have just put the right path to the training, validation, and test set. You have also the number of classes, so 26 for the 26 letter of the alphabet, and the names of the classes. OK, so that's it for the data. I will give you the notebook at the end of the presentation, the codes and the slides, and you will be able to play it after. OK, I have already cloned the YOLO V7 repository. Once again, you can access to this repo. You can do some training, some detection, some tests with the model. And I have also installed my requirements. So in the requirements, you have, for example, PyTorch, OpenCV, and other one. And I just need augmentations to do some data augmentations after, and 1 dB, so weight and biases, to see the evolution of my model. OK, so we will play with the notebook. So first, we import the dependencies like that. So here we need, for example, Torch, also Torch Vision, probably Shuttle, and YAML. I will log into weight and biases. So probably I'm already logging. OK, I have a through. And something important, I will check if I have some GPUs available. So here I can see that I have a Tesla V100S. OK, next step, I will define the number of classes. So I will just take the information in my data.yml file. So I will have probably 26 classes. And I will also check the YOLO v7 architecture. So you can custom it if you want. Here I will use a model like that. Okay, so that's for the architecture. Now I will recover YOLO v7 weights. Why? Because we're going to use the transfer learning power. So you have to know that YOLO v7 has been trained on the COCO dataset. COCO is a large dataset for computer vision. You have 330,000 of images. You have also 80 classes of daily life, for example, cars, people, pets, and food. And the model has been trained on it. By using transfer learning, my custom model will be probably better and I will save time. So let's go for the download. It will be very quickly. And you have to know that this model is available on the YOLO v7 repository on GitHub. Okay, so it's done. Now it's time for the training. I won't have the time to do it in live because it takes around 45 minutes. But I think it could be quite boring for you. But I will explain the command. Something important, so of course the train.py file. The device, so it's a 01 because we have only one GPU. After that, the data with my data.yml file, the images size, my model architecture, the existing ways from YOLO to do transfer learning, also the name of my project, and to finish the number of epochs, so here 100. I have already saved the results, so let's go. Okay, here you can see the sum up of the results with some graphs. I won't have the time to explain you all the graphs, but you have all the information of the notebook. Just quickly, here on the top on the left, you have losses for the training. So concerning the boss, the objects, and the classification. After that, you have also the losses for the validation set, with the box again, the object, and the classification. On the right, on the top, you have the precision and the recall. It's to see how the model is accurate. And you have also the maps. We will just check on weight and biases, because you can see that the tool is very useful to do it. Indeed, if I will check, for example, the precision, I have all the information for each epoch. So it's very useful, and we can see several things, and we will see after that to compare models, that's perfect. Okay, so back on my notebook. So all the explanations here about how to calculate the precision, the recall, also the IOU for intersection over union. And now I will do a test. I will use my weights generated by the training. So here I will just check the weights. You can see that we have the best one, so we're going to use it. And we will do a test on the test set, because before we have used the training set and the validation set during the training of the model. Now we can use the test set. So once again, the data.yml file, the same size for the images, and our own weights this time. So you will see that it's very quickly for the test set, and you have several results about the metrics, and not about the losses this time, but you can see for each letter how accurate my model is. So for me, that's okay, but it could be better. We will see how to do it. We will use data augmentation power. So we won't create a totally new dataset. We will use the basic dataset, and we will do some data augmentation on it. So there are several tasks of data augmentation. In our case, we will use the brightness, for example. We will use also the horizontal flip, so it's a mirror. We have the rotation, so for example here we have 60 degrees. The saturation of the image. And the last one is a translation and grayscale. Something important in object detection, even if my box is here on the basic image, it has to be here on my resulting image. How to do it? We can use augmentations that you can see here. It's a framework dedicated for data augmentation, especially in computer vision, and we're going to use it. I have already a notebook open. I will use it. OK, so how to do it? First, I will create new directories in order to put my new data in. So I did it before. I won't do it again because data augmentation could take some time. So that's for the creation. After that, I have to split my data. I have created a Python script for it. So here, again, my function in order to create directories. And after that, I will split my data. Only the training set, how to do it. I will split it randomly in 5 groups for the 5 tasks. And for each part, I will split the images and after the corresponding labels, of course. And at the end, you have the main in order to do it for the 5 tasks. OK, so that's it for data split. After that, I will just import the augmentations library and CV2 for OpenCV. And let's go for the task. So you can see that it's quite easy to do it. For example, for horizontal flip here, I just put a probability, so 80% in order to do it. The format, so here, yellow, and the categories IDs, so the number of the classes. That's the same for the rotation, with 60 degrees here. And we have also to play on the saturation. Again, a probability of 80. And the last one, translation and gray. And this time, again, we apply the image to gray with a probability of 80. Once again, I have created a Python file for it. So I will show you the function. So once again, the creates directory function. And after that, we have some extraction to do. Indeed, with YOLO, we have txt files labels, and we can't use it like that. So we will extract first the name of the classes and the IDs from the data.yml file. And after that, we will extract the boxes. I will just show you an example of label. OK. So here you can see several things. That's an example of label in txt format. You have first the classes. So here the 0 for the A. After that, you have the coordinates of the center of the image or the box, and you have also the width and the height. We can't use a txt file, so we will convert each txt file into a list of lists of, we can also call this a matrix. So I will do it here. I will extract my information, and after data augmentation, I will do the other things that we will convert each list into a text file. So we will call the data transform function, and we will use it in the main. I did it before. It could take several hours, and we won't have time today. But when my data processing is finished, I will just copy my new images with the old one, and I will have a better data set. So I have launched a second training with my new dataset, and we will see the results. So weight and biases again. Okay. So here you can see in orange the first training on the basic dataset, and in blue the training with the augmented dataset. You can see that the results are better. For example, if I check the precision, I have now around 93%, and before it was 84%. So my model looks to be better. If I check the losses, I can see that there is a big difference, and I think that's good. We have a better model. So back to the notebook to test my new model. Okay, I will take the best weight again, and I will test it. So it's the same test set. We will just check if my model is better on it or not. Probably yes, if we look at our curves. With weight and biases, you can also check the GPU consumption. So here, for example, you have the percentage of consumption. Why in blue the training is longer is because we have more data. Logical. Okay, so I think the test is finished. So for most of the letters, the results are better. So that's something good. That's what we want. Now I have created a little set with my own images to test my model. So this one, for example. And we will do a detection. Okay, so I will do some detection of these images with my new weights, and we will see if the results are good or not. Okay, so here we have the summary. I will just check the resulting image. So in YOLO v7, runs, detect, and I think this is this folder. So yes, I have a V. Probably I'm an M, but okay. Once again, it's a POC. I have a W, that's right. An L, it's okay. An R, right. And here you can see that we have a U on the front. That's a good response, but on the back, it seems to be another box. Okay, so I have tested my model. Now I can export my weights to an object storage container in order to use it in an app. Indeed, we won't use the model only the notebook. We will develop and deploy an app thanks to AI Deploy. So back to the presentation. You will have the summary of the results here on the slides. The same for the losses. And before testing my app, I will just show you the code. So all the code is available on GitHub. Okay, so first, the Python file. Okay, so I will import my dependencies, that's okay. And I have created my app with Streamlit. Streamlit is a framework very useful for data scientists and machine learning engineers in order to develop a Python app for AI very quickly. And here I will use the Streamlit cache in order to load my model and only one time and not each time I run the app. So I will use a custom to use my own weights. Then a get prediction function to call my model to have the results. And the biggest function is the analyze image. We will check if there is an image or not. We will transform it, and we will encode it in order to be able to have the results of the detection. And at the end, we will just put our results in a list. Okay. Then the last function is to display the letters on the interface, and I will call all the functions in my main. What I want to show you is a Docker file because it is very simple. as you can see, I have just my origin image, which is a Python 3.8. After that, I have the working directory, so the workspace. I'm just installing the requirements.txt file with all the dependencies inside and my command. The specificity is just a user for OVHcloud. But in 12 lines, sorry, it's okay. Okay, so I know that you want to test it, so let's go for the test. Okay, I think you will see my screen. I will just put the micro on the table because I have just two hands. It could be quite complicated. Okay, so here I try to do a no. It seems to be a G. So we will try another letter. Okay, that's good. It's a V. The probability seems to be good. You can see that I can write a text. The aim at the beginning was to write OVH. It's not the case, but anyway. We will try the H. Okay. Nice. It's just the O, but we haven't got a O. And if I want to clear my results, I can do clear results. And I can write OVH very quickly to see the good results. Okay, once again, it's a POC. It's not perfect, but it could work. Okay, nice. Let's go for the conclusion. Today, we have seen that we can train a model with GPU power thanks to AI notebooks. We can also improve an AI model thanks to data augmentation, even if the model is not perfect at the end, I know. We can store easily and securely the AI model in an object storage container. We can build an AI app, and we can use the trained model. And we can deploy it thanks to AI deploy with security and high availability. If you want to test it, I have the QR code. You can test the app. Please be careful. The app is not perfect. You will have some particular results, I think. If you have any questions, don't hesitate. I will put the slides on my social networks, so LinkedIn and Twitter, for example. And thanks for listening. Don't hesitate for the question.
Thank you, Elea.